Cool. Welcome everybody again to our MakerBot Pro webinars. I'm happy to be joined by Max Kirsner here from C4 CycleWorks. Hello, Max.
Good to be here. Thank you for having me.
I just want to check before we get going that everything is okay. Let us know that we got Julia, Anastasia, and Mateo in the behind the scenes helping us take this to you guys. So let us know if you're hearing any glitches or the audio quality is not working for you guys. Otherwise, we'll get started. So, hi, Max.
Hello.
I'd like to start just, kind of giving a rundown of what brings you here. I guess, your quick intro of who you are and what you do at C4.
Okay. My name is Maxwell, like I said, and at C4 CycleWorks, we build custom carbon fiber bike parts, and we also do fabrication and repair, but we like to focus on building bicycle parts, high-end track racing parts, also triathlon and time trial parts, but mostly track cycling parts that are over-engineered and beautiful and, for the most part, carbon fiber.
Right. And full disclaimer, I'm a big fan of Max's work. I love bicycles, and that's one of the good things that has worked about this. So, if we go to our deck, I'll start by saying that the relationship a little bit started because you have a lot of experience with the C18. If you go to the next slide, and then you have that on your shop, and we paid you a visit, and we noticed that how are you kind of mixing the different products, or I would say machines that you have in your shop. We'll touch on that a little bit too. And now that we have the method available, which by the way, it's shipping now. How can we envision the two printers working with other machines, right? Because it's never one kind of a one-stop shop where you can have one machine do it all. You can have the CNC work with the printer work with the carbon fiber in your case. But let's start with the use cases that you've seen. So if we keep moving on, we'll see an image of what's her name? Robin Stewart, right?
Yeah, Robin Stewart, who I built.
So you'll have her now on camera. But yeah, what's her story and kind of how did you connect with her?
So Robin Stewart and her coach she's a cyclist for Ireland, and she needed a bar that was much narrower than any bar that was available on the market, and she needed a stiffer setup because the type of racing she does really it benefits from having a stiffer setup because it's such a short race. Generally the races are either 60 seconds long or 12 to 10 seconds long. Very short races, and power transfer from your body into your bike output is better when you have a more aerodynamic and stiffer setup. And so there was nothing on the market available for the size that she wanted. She wanted an incredibly narrow bar, about 26 centimeters in width, which is very
10 inches.
That's about a foot.
Yeah.
And there was nothing that size available. 26 centimeters, and so they contacted me, and I got all of her information like I usually do between the type of bike she rides, the geometry of the bike she rides, the geometry of her body, and then we build a custom bar and stem which are integrated together, which allows for a stiffer end product because the design is integrated, which is super cool. And we ended up building her bar, and now she races on it. She loves it. It's a beautiful bar, super aerodynamic, and it's really cool.
So let's talk a little bit about the process of building the bar, because we have one here, one of the printed bars actually. It's, I would say, a different model than what she uses, but it's also one of your models, right?
Yes.
So for the final one, of course, and this is kind of where we start talking about the mixing of the technologies, right? You're not printing the final one. But you are printing it for a reason. So how do you get started? Once you have the dimensions, you see that the model has some sort of life to it.
Yeah.
Then you print it for what?
Okay, so kind of where the Z18 meshes with the design and building of the bars. So in Robin's case specifically, I build the bars in a jig that holds the geometry in place, so that I know that no matter what I cut or what I build or what I mesh together in real life, not digitally on a computer, that the geometry will still be straight, because you don't want to put a bar on your bike and have the grips be not level, or have the grips be too short or close to the center on one side than it is to the other side. And so in Robin's case, what I did was I 3D printed this jig to where the bar would like mesh on one side and mesh on the other side. And what this did was it held it perfectly level to the ground and level to itself, and level and perfect geometry to the stem, so that I know along this axis, and the relationship between the grip and the stem would be perfectly straight. And I did that by 3D printing a jig that was the exact dimensions I needed to build the bar that she got.
Right, and that's one of the things that often gets overseen a little bit in printing, right? Where you're not always printing the final product, but actually a tool to create the final product, which is also as important sometimes.
For sure. And I actually, none of the things I print are the final product. They are tools to get me to the final product, and that's where it becomes incredibly useful. The Z18 and 3D printing is that you can either print a dimensionally accurate version of the final product, and that will let you kind of plan your plan of attack to make it better by being able to hold it and have a tactile feel of what the final product will be like, versus just looking at it in CAD and looking at it on the computer, and you really don't get a sense of the design until you physically hold it in your hands. And being able to hold it in your hands before you've invested time and money in making a final product is really beneficial, and it's really helpful.
So, and we'll talk shop a little bit in
Sure.
a second, kind of what your whole setup is. And we also have another example that I wanted to bring here, kind of to get things started.
Yeah.
It's another handlebar here. If
And
you
the
go
crank, I made the crank.
Oh, and the crank,
too.
right.
Yeah.
That's a beautiful bike, by the way.
Thanks. Yeah.
So let's touch on a little bit first, kind of introducing the materials behind cycling, right? Because most people maybe assume that it's just one material, maybe steel, maybe aluminum, but in this case, you have a lot of different materials that are placed throughout the bike, and then also what you did in this case specifically.
Okay, so those are two separate things, but with this bike is like 95% carbon. There's very few metal things on this. Maybe the bearings, the chain, and the mount that holds the saddle down. But almost everything else is carbon fiber, which is, it's not super common, but this person, when they came to me and they said, hey, Team Great Britain has these bars that look like your bars, but they're not available to the public. They're only made by Great Britain's cycling development team for their athletes. And he says, I'm not an Olympic athlete, but I race at a high level, and I want similar bars. And so I said, you know what, we'll make you similar bars. Not an exact replica, but very close. And so what he did is he took a similar frame, because the frame that Great Britain rides, I don't believe is available to the public, but he took a similar frame and he painted it to match. And so he got cranks that I made that are similar to the Great Britain cranks as far as looks and feel, and he got bars that are similar to Great Britain's bars in looks and feel, so that he could recreate this bike that Olympic athletes from Great Britain, from Team GB, ride on, but aren't available to the public. So
right, and kind of what you guys are seeing as context in the screen right now, it's the three sort of main materials that you're using, right? It's, moving from PLA to carbon or aluminum, depending on the application.
Correct.
But if we go back to kind of where we were with the with the bike itself, right? You can see that there's a lot of customization happening, right? And then that's where it becomes important to be able to have, in a way, the freedom that the printer will give you to recreate any shape that you want.
Definitely.
Especially when you're replicating the...
and these shapes, the shapes of the bars specifically are very organic.
Right.
It's crosses all three axes multiple times, and being able to do that from the base with CNC is very hard, because with the majority of affordable CNC machines, you just have 3-axis abilities, whereas this, for something like this, you really need to be able to get at 5 axes.
Right.
And to do that in 3D printing is really simple, because you can print supports, and you can support things from the bottom, which you can't really do in CNC.
Right. So, now that we have your picture in the shop, let's talk a little bit about the setup, which was one of the things that we, really liked when we first started talking with you. The fact that, it's never a single solution, right? We do know, and of course, we love 3D printing, but it's kind of a means to an end, and it complements other processes. So I would like to, if you can describe to us and to our audience back home, what's the setup that you have? What are the main machines that you have? And if we keep going to the next slide over, we'll see a little bit of the overview, but if you can touch on each of them.
So I have, as far as 3D printers that I use regularly, I have a MakerBot Z18, and I have a Replicator Plus 5th gen. And then that's on the additive side. On the subtractive side, I have a Shapeoko CNC 3-axis kind of milling machine. And both definitely complement each other, because I use for the even just modifying and building the CNC machine, I use a ton of 3D printed parts. Even like this is a jig that I printed out to maintain a continuity and exactness across the x-axis. So when I clamp something down here and when I clamp it down here, I know that if I also clamp something down here and here, they're the same relationship here and here, by having this kind of like jig piece going along the center of it. And I did it on the Z18, which is pretty cool.
So it's interesting to see that in a way you're sort of creating your own tools in the shop, right?
For sure.
It's not only creating the prototype itself, but I guess building aids or constructing aids. How would you describe that as a thing? Right? Because we started with some of the jigs that you have, but what does it mean to create your own tools sometimes?
So a lot of jobs that you're doing when you're doing like custom work are one-off jobs. And so spending a lot of time and a lot of money doesn't make sense if you're only going to use the tool once, because you're making something that's custom for one person's body, where you wouldn't need it again, because no two bodies are alike. So being able to 3D print a part inexpensively, not the part but the tool to make the part, is effective in that it's quick and it's inexpensive. And the Z18 having such a big build volume means I don't have to separate prints into like 3 or 4 parts, and I can get a really structurally accurate part or a tool to make the part that I want. It's been very helpful.
And it actually, right now we have, if we pan to the left a little bit, we have your handlebar printed out here on the Z18.
Yeah.
And it speaks to the volume, right? It's kind of challenging altogether to print such a big part in a single go, but there's benefits for that. Specifically, the fact, as you were saying, kind of, it comes in a single go. I have it here with supports too, right?
Yeah.
So the Z18 will only print on a single material, right? But what does that mean for creating these overhanging structures when you're having to use support on it?
As far as supports, in
I guess the reason behind having to have supports in 3D printing, right? Because it's unlike subtractive, and we'll touch on that in a second. But unlike subtractive, you don't have anything to accompany the part as you're building it, right? You're sort of creating it as you go.
And so the supports allow you to create the bottom side of the print that you need. the overhang. So if you were to like mill this out of a solid piece of metal, you would have to cut the top and the bottom, and you can either do that on a 3-axis machine where you cut it like this, the top, and then you physically flip it and cut the bottom, and that's 2 operations, and getting them to line up is not always super easy, because if you cut the top and then you flip it and you're, you know, half a millimeter, a quarter of a millimeter, 1/10 of a millimeter off, the top and the bottom don't align in your final product, and it's, you know, bizarre.
And expensive.
And expensive.
Yeah.
Or you could use a 5-axis machine that could hold it and cut all the sides of it, but then you're looking at a machine that start at like $100,000.
Yeah.
Whereas in a 3D printer, you just have the supports that are, you know, automatically generated to hold up the bottom side of the print, and that allows you to be able to do it all in one go, which is, you know, a great feature.
Yeah, and you know, as we start talking about, you know, the 2 main technologies that we're discussing, additive and subtractive, so going on kind of in the slides, but let's just stop for a second and make sure that we're on the same track as, you know, describing both of them. So additive versus subtractive, and what are the benefits and challenges for each of them?
Okay, with additive, when you're talking FDM and plastic parts, the advantage is that they're quick and they're very inexpensive, and you can rapidly prototype, change design very quickly, and because they're inexpensive, you can trial and error and not have to worry about material costs. When you can get a spool of PLA or whichever material for real cheap now, you can afford to mess it up or try something crazy or you know, go really far out there. And so with additive, you know, that's the advantage. Time, inexpensive, and, you know, you have the ability to create very organic designs. And it's much easier to do a very organic design in additive than it is in subtractive at a affordable, you know, price.
And what about subtractive? Because it's also, you know, we're not trying to say that that's not meaningful. They're super important.
Super
also
important and very different. You know, they're very different ends, and so subtractive is very important because the material that you can cut is, you know, can be as strong as you need it to be. It could be, you know, you can cut titanium, you can cut aluminum, you can cut steel, and it's really 3D printing isn't there as far as affordability using those materials and getting that strength. But it's also, you can have very accurate subtractive projects, and you can really build some incredible things. But when you know, combine the 2, you can then kind of get the best of both worlds.
Right, and in a way, it's kind of interesting that back and forth that happens not only in the part, because you could, you know, as you were describing with the handlebar, printing the handlebar first to get a feel for it, and then once you're ready, maybe you'll carve it out of a block of aluminum, making sure that you understand the shape, it's going to work for you. But then also complementing the CNC mill with, I think what we're seeing here in the lower left corner is that sort of the idea of you always need some sort of jig, and we were talking about it before we got started, kind of having a jig that will allow the machine to perform and to find its zero in a way. We were talking about
that's kind of where I use my Z18 in relationship to my CNC machine. So there's a couple things that I do that I print that are incredibly helpful. So this is one jig for the CNC machine that I use to find what's called the work coordinates, where you need to find the 0 point where 3 axes meet. So if you have something that you're going to machine, say for me particularly, it's the circle in
Mhm.
this hub. And I need to find where the one axis goes this way, where
Mhm.
one axis goes this way, and where one axis goes this way. And so if I 3D print a jig like this, it's kind of easier to tell that this finds this point that I need, where this axis meets this
Mhm.
axis and meets this axis.
Mhm.
And so that's one of the interesting things I use 3D printing for, is finding exact work coordinates.
Uh-huh.
And then the next thing that I use my 3D printer for in CNC is work holding solutions.
Mhm.
And work holding solutions are work holding where it parallels the 3D printer is kind of like bed adhesion.
Uh-huh.
You need to be able to hold the material that you're cutting down, say it's metal or composites or whatever you're cutting, wood, and you need to be able to hold it down and have access to all parts of it. And so if I take something like, if I want to cut something like this out of aluminum
Mhm.
or carbon fiber or whatever I'm cutting it out of, I need to be able to hold it down, and but the issue is I need to have access to the part underneath where I'm holding it down.
Mhm.
And so when I'm cutting something like this, I'm taking a 12-inch by 12-inch piece of aluminum that's maybe a quarter-inch thick, imagine like a book, and I'm bolting that book down in the CNC machine. And in my before, without a 3D printer, you kind of just have to imagine the final part. Like if you're sculpting and you have a giant rock and you just have to imagine the sculpture in there. But with a 3D printer, I can actually 3D print the final part. I can bolt that piece of aluminum down like a big metal book bolted down to the table, and I can overlay the final part that I want on top of that big piece of metal, and I can say, this is what I'm making out of it. Where do I need to hold this so that the CNC machine can get to all parts of it without where I'm holding it covering up any of the final part that I need to cut. So, it's very helpful in that case, in that sense, in work holding.
Right, and it's interesting because even as a trained engineer,
Mhm.
myself, I'm a trained industrial designer, but sometimes it's hard to sort of get your head around these geometric problems where it's like,
Yeah.
okay, how do you hold down a circle in a circle where you want to cut the inside, you want to cut the outside, so where is it that I'm being able to
Yeah.
bolt it down?
And it gets very tricky.
Right, and it's not always obvious, right? And when you
sure.
see it in the computer, or at least it happens to me. I don't know if you have a similar experience, but you can see this in the computer. You can orbit it however many times you want, but it's kind of never really there for you to feel and really
Yeah.
understand and get a grasp for it. So,
And a lot of times when you have it on the computer,
Mhm.
you have an idea of the process you want to use.
yeah,
And then when you physically have it in your hands, you're like, oh, I have a much better idea.
Correct.
Because then
yeah,
you see that, the original solution that you had wasn't as good as the one that you could have once you physically are holding it and say, that original idea wasn't as good as
Yeah.
this next one that I have, because now dimensionally I have an accurate final part, or a representation of the final part,
mm-hmm.
and then it allows you to come up with better ideas. In my mind, it does, at least.
And in a way, and to use this as a segue, the interesting thing is that you also want to be able to kind of prototype that idea cheaply and easily, right? You want to be able to make a mistake because you know that you will make a mistake.
For sure,
I think we at some point started talking about it as in MakerBot as having a 3D sketchbook in a way.
Yeah.
Because you want
That's
something, just scribble something,
Yeah.
right? You get the idea of the handlebar, you draw it on a piece of paper, and you don't really think about, hey, is this post-it going to cost me too much? Am I spending too much ink from the marker?
Exactly.
I feel like there's something like that in the printer as well.
For sure. And you kind of hit it nail on when PLA is so cheap now that you could just try ideas, and you're not limited by the price of the print. the value becomes more in time. You know, your time is now the biggest value versus the cost of the material. You know, and it allows you to rapidly prototype, which is, you know, super value adding.
So if we go back to the slides now, you will see kind of again going back to that price comparison of the raw materials in a way, right? So we have PLA, we have carbon fiber, and we have aluminum, the three materials that you mainly use, right? And it's kind of deceiving to talk about prices at this point because of the way that they'll I don't know, the actual price behind the part. And we're not saying that any one will be, again, the solution for everything, but you want to make sure as you move or as you progress in this development.
And there's varying grades of each material that cost differently. And so, PLA and carbon fiber and aluminum are the main materials that I use. And they are very different to work with, but they all kind of complement each other because they're all kind of moving towards the end result. And, you know, each one is great in its own aspect, and being able to have access to all three kind of creates a better final product, which is awesome.
And I was like, you know, initially I had it in the kind of rookie mistake, but I had the carbon fiber stated out as a I guess price per
pound,
which makes little sense. But let's talk a little bit about, you know, the materials and how they usually come. And so in the case of PLA, and speaking about MakerBot materials, they just come in a spool, and you just, you know, fairly easy to buy them at bulk, plug them to the printer, and you're good to go. What about carbon fiber and aluminum?
So carbon fiber comes as a fabric. There's many different kinds. There's many different grades of quality, and then there's, like anything else, there's many different places it comes from. You can get American carbon fiber, you can get German carbon fiber, you can get Japanese carbon fiber, you can get Chinese carbon fiber. Some people believe some are better, some are better. But you can get, the way carbon fiber works is it's woven strands of carbon, and depending on how many individual strands there are per weave, kind of determines its strength. So if you look at like a piece of carbon fiber like this, so you can tell, this one's ground down a little bit, but you can tell that the carbon fiber is woven like this and like this. And in each individual strand of the weave, there's different amounts of hairs of carbon fiber, and the strength is determined by how many of the individual hairs of carbon fiber are in each weave. So something like this has, in each line, has about 3,000 strands of carbon fiber, and there's 3,000, 6,000, 12,000, 24,000, and like 50,000, and then it gets pretty crazy once you get into like aerospace kind of stuff and building planes. But for bicycles, I generally only use 3,000 strands, 12,000 strands, and, you know, maybe 6 depending on what I need. And then, you know, there's other composite materials, Kevlar, aramids, graphite, all sorts of crazy stuff out there now.
So without trying to open a whole can of worms about, because I think it's really impressive, you know, 3D printing carbon fiber, but there's an interesting kind of, for me at least, a disconnect when talking about something that is carbon fiber as a fiber, kind of like, I was just sketching it out as you were describing it, but it is pretty much a fiber similar to, you know, any type of
it comes as a fabric. It comes as a dry fabric.
But if it's, you know, when you print it out, it has different properties than when it's a fabric, right?
What do you mean when you print it out?
So there's certain
you mean
machines,
like filaments with
right.
Okay,
right.
So yeah, there's a lot of machines that print carbon fiber now. Well, not a lot, but there's a few carbon fiber printing machines, and you know, there's a lot of debate on whether their printing is better than regular FDM. And it's something you could research, but my theory is that there's two types of machines. There's ones that print that has usually PLA with chopped strand carbon fiber, meaning they take a lot of fiber, carbon fiber, chop it up, mix it in the PLA, and that creates like an internal structure. And then the other type, which is generally more expensive, is the machines that add one strand of continuous carbon fiber in the head, in the heated head of the printer, and then kind of wrap it with PLA so that each line of 3D printing has a strand of carbon fiber in it. And there's kind of a debate on whether or not that is better or adding a value. My personal theory on it is that carbon fiber.
Oh, we triggered the printer. Sorry. That's good.
Tight quarters. All right.
Yeah,
So-
it doesn't look like it because we have a white lens over there, but we are pretty close together.
All right. So
Sorry about that,
can,
but yeah.
can you see this drawing?
Yeah, if you can
Okay.
like zoom in
So-
here.
So the way that carbon fiber works is, for the most case, it's woven together like this, and the strength of carbon fiber comes along its axes,
Mhm.
this axis and this axis, and it's very strong along those axes from axial pressures. If you imagine the analogy is like a pencil,
Mhm.
it's very hard to crush it along the long ways.
Right, if
but
I try
you-
to
yeah.
squeeze it like that,
It's very hard to crush it, but you could snap a pencil very easily.
Mm-hmm.
And so when you 3D print a continuous strand, you don't gain the weave.
Mhm.
It can't weave because it's one continuous strand, whereas carbon fiber has multiple strands that are woven together. And so this type of end product will always be stronger. Now, is a carbon fiber 3D printed part stronger than a regular FDM part? Probably,
Yeah.
but it
But
doesn't
it depends
ever
on the
come.
application.
It depends
right?
on the
Uh-huh.
application,
Mhm.
and it depends on whether or not, that tends to be for more people where the printed part is the final part.
Exactly.
My parts are generally just tools to get to the final part, so I don't need the strength, I just need the dimensional accuracy.
Yeah, and I think that that's something important to discern in the conversation, because it's, as we keep repeating here through the talk, is like the fact that it's never a one-stop solution, right?
Mhm.
It's like there's benefits, pros and benefits from each of them, and I think that the important thing is like how do we understand each of them, each of the
Yeah.
processes, each of the the things that come and go with
Yeah.
it, and the fact that if you want to have the compliance, kind of the behavioral properties of the carbon fiber, you need a fiber. It's
Yeah,
hard.
you need carbon
As
fiber.
you were describing, it's like you need a couple thousand strands per
Yeah.
inch, not just one strand accompanying it. It's a different product, but it'll
Yeah,
help.
for sure.
And then talking about aluminum, right? Because that's where it can also get a little bit pricier, but it's also super important because there's many things that have to be aluminum. We were talking about this lock.
Yeah.
Sorry, Luke lock. What's the name
Look.
of it?
Yeah,
Look.
yeah.
Yeah.
So- Yeah, aluminum is one of the easiest materials to mill and to use in a CNC machine as far as metals go.
Mhm.
It's a relatively soft metal, but it is a still very strong metal. And so what I do for when I make aluminum stems is I will 3D design it first. I'll 3D print it, and then I'll actually put this on the bike, and I'll make sure that this fits exactly how I want it to fit. The length is right, dimensional accuracy is right, and then once I have the final design, finalized, then I'll look at how I'm going to make it in the CNC machine, how I'm going to cut it, how I'm going to do the work holding, and from there, you come out with a blank, and then that blank gets refined down, and then it gets finalized to that, and then you can kind of compare from the 3D printed one to the aluminum one. Is it correct? And for me to go through all these processes in aluminum without verifying that it'll fit on the bike the way that it's designed to is it's expensive and time consuming. But if I could 3D print it out first and verify that it works, that's incredibly helpful. And this is a particularly easy design. There's nothing super complex about this. But when you get into like more complex shapes, this is another stem for a look bike, where the ridges have to be incredibly accurate because a piece has to almost press fit into this hole. I got that accuracy down by 3D printing it like 10 times to know exactly how much give I needed to build into the part first. And if I had to cut 10 metal stems, it would have been time consuming, it would have been expensive, but I did it for about $4 in PLA. You know?
Right. So, and then just so that we all know, because, you know, maybe clarifying what the stem is. So basically this is a connecting part that goes from the handlebar into the actual, fork of the bike.
Yeah, from
right?
the fork to the handlebar, it's the connection.
And it's funny how I know that these parts are not meant to work with each other, but it's here. It's like you can almost see how the bike starts taking shape, right? It's like the handlebar, and then it's sometimes it's that is what you need. You just need the understanding of the shape, being able to say, okay, I'm trying to create a bike. I'm trying to create a connection between these two parts. Is this working for me, or is it not? Before I move forward into the actual milled part.
And the tactile experience of it is so important because it's, if you don't have a 3D printer, or if you never dealt with 3D printers, but you're from kind of an engineering background, you cannot, maybe you don't understand that in designing and building, you look at a computer a lot. You could work on this design for days and days and days, and then when you think you have it right, like, it's just in your mind that you think you have it right. That there's no actual proof. You've just tweaked it and tweaked it and tweaked it, and then you kind of, you know, until you physically hold it in your hands, you don't know if it's right.
Right.
Which is, you know,
and actually, you know, going a little bit back to the deck, I ran a kind of a silly exercise of what would happen if you have the same the same handlebars out of PLA, out of carbon fiber, and out of aluminum. It sort of, in a way, doesn't make sense. So bear with me for a second, but I would never want to write a PLA bar, right? Because even an ABS one, it's just
no, any FDM plastic part is not structurally strong enough.
There's a purpose for it, which is just the form fit, the understanding.
Exactly. It's not the idea to make it structurally strong. If somebody came to me and they said, "Hey, I want this design, I want this bar, I want this completely custom, not something off the shelf," and they wanted me to build something that's specifically for them, for their body, for their frame, there's a lot of time and a lot of money that's going to be involved in that, and they're going to be, I'm going to have to ask them, as any custom builder would, to spend a lot of money on a part that they want.
Right.
And for me to say, I can show you what this part will look like and feel like in a matter of a few hours, or depending on what it is, you know, 10, 20, 30 hours, and they can hold it in their hands, and they can actually put it on their bike because it's dimensionally accurate, because it fits the way it should, is incredibly helpful to get people to understand and feel what their final product is going to be like, versus me turning my computer around and saying, this is what it will look like.
Yeah.
The difference between saying this is what it'll look like and this is what it will feel like, because they're physically holding it in their hands, is immensely different.
Yeah. And then, you know, going through the process of or the silly example of the final product in carbon fiber is going to be a couple grand, right?
Yeah, depending on what you want, depending on what your level of customization and how much work is involved, some of these products can take 100 hours of labor.
Yeah.
And carbon fiber is not a cheap product, but there are some affordable solutions. But you know, if you are looking for a custom carbon fiber part, you're looking, you know, $800 to $3,000.
Yeah.
And you know, it's not really comparable in structurally, but when you're talking about this physical part, you know, cost $5 to make, but the same dimensionally accurate physical part in carbon fiber would cost $600 if I were, you know, to sell.
Right,
you know?
right. And then finally, kind of like that example of the aluminum, you would never want, especially for
you would never want a solid aluminum bar, but if you wanted not this particular bar, but the bar in the picture, a solid chunk of aluminum, you're talking about starting with a piece of aluminum the size of, you know, a crate.
Yeah,
And it's
and it gets
not
crazy.
cheap.
But
Yeah.
and then, sometimes you need that. But the point is,
Yeah.
by the time you're ready to commit with such a big chunk of metal, which is
Yeah.
going to be pricey, you
Yeah.
better be sure that you know what you
Yeah.
want and you know what you're carving out.
And dealing with carbon fiber and working with carbon fiber, I work with a lot of molds. I make a lot of molds out of aluminum, and aluminum is not cheap. It's not cheap material, especially compared to PLA. So when you are going to commit to making a mold, you have to know that the mold you are designing and the mold that the final product you're trying to make with that mold, that the mold is exactly right before you even start cutting it, because once it's cut, it can't be uncut.
Right.
So I will 3D print the molds to test them for accuracy, to test them for the process, and make sure the process of making the carbon fiber part is going to work with that specific mold, because these molds are of very organic shapes. And if I'm making a mold for something like this, it could be like a 6-part mold, and it could be pretty expensive amount of aluminum. I'm talking probably, it could cost $1,000 worth of aluminum, and if you mess that up, that's $1,000 you threw away. So I will 3D print them more than once, just to make sure that they are right. And I might tweak an edge, I might tweak, a little design in it, just so that I know not that the final product is right, but that the process of making the final product is right. And 3D printing allows me to do that.
Cool. And you touched on it, if we go back to the deck, it's like it also depends on the number of parts that you're having. And I'll just touch briefly on it, but it's kind of borrowing, from 3D Hubs. They had this great graphic explaining when does it make sense, or how does the pricing compare for different options, right? Additive, subtractive, or forming. And by forming, we mean like injection molding. So not something that we've discussed here, but still, it all depends not only on the application, but also on the number of parts that you're doing, right? If you have something that's highly custom, it's just one of, it makes more sense to print it. If you have something that's millions of units, or at least a couple 100,000 units, it makes sense to have a mold, and it's going to be an expensive mold for that, so you might want to make sure that it's the correct one. But being able to trust the fact that what's coming out of that mold is super important before you commit to that. And then, if we move on, I wanted to touch on also the fact that it's kind of a brand new product, so we haven't had a lot of time to play with it, but we had the opportunity to use Method for one of your parts here. And actually, I have a part printed here in the back. You can see it in the printer. I'll take it out of the printer because I printed it overnight. It's covered in, and I'll show you guys what it looks inside. Right now, it basically looks like a big cylinder. But it's if you come like. So basically, what we printed is a hub, right? Let's it's a bicycle hub. A hub for a wheel, right?
Yeah.
And you were trying to fit that part in. So let's talk about a little bit about that. Yeah.
So the design for this was that I'm planning to make a carbon fiber shell that has an aluminum hub that bolts into it. And so I 3D printed the shell, and then, dimensionally correct so that I know the final product would be correct and accurate, and see where it needs to be tweaked, and I could see, where the design process either needs to change or is perfect,
Right. And we were talking about, when we first saw this part, the price of this is not a cheap part, the inside, the actual bearing in the hub, right? And it's a very accurate and precisely created component, right?
Yeah. And expensive to make the prototype, for sure.
Right. So what happened when we printed out, because you were using initially the C18, and the C18 is kind of, we know that it's better fitted for those large parts, the quick iteration, but what happened when you started seeing the prototypes that we printed on the Method?
So the Z18, it prints very accurately, but it's not incredibly, precisely accurate. There is an amount of minor
it has a different tolerance.
The tolerances are completely different. They're not bad by any means. They still get very accurate parts, which, if you learn the machine, you can get great tolerances out of it. But there's the tolerances for the Z18, I believe, are designed around a giant build volume. And when you have such a large build volume, where you suffer is maybe the tolerances aren't incredibly tight, but they're still pretty good. So when I designed this particular hub, I designed it around the tolerances I knew I would need to offset. And to do that, I made the hole specifically a little bit larger, maybe 0.5 millimeter, than I knew would be like a zero tolerance fit, which by the end product is too big, but for prototyping was fine. If I knew, it didn't matter because I knew this wasn't going to be the final product. This was just going to be the test, And when I printed that extra 0.5 millimeter, it fits perfectly.
Yeah.
And when we switched over to the method, you don't need that extra to design in that extra tolerance. You could just go zero tolerance or a couple microns out.
Yeah.
And you get an incredibly accurate part, which is
and I think
awesome.
at least what I like is the fact that they sort of complement each other, right?
Yeah.
It depends on the application, and it goes back to having that ability in the shop. And we know that any workshop is not going to rely on a single machine. It's going to need to understand what are the processes that I need to take into consideration. How am I going to create this part? Even the fact that, hey, how am I bolting this part to the surface? And for that, I'll keep going into the slides, and then, looking a little bit into what happens when you have a machine, a 3D printer accompany a CNC router, right?
Yeah.
So if we talked about how important it is to bolt things in CNC, where it's not just
work holding. Yeah. So the 3D printer, like I said before, it really helps with work holding, making sure that the CNC machine can get to all parts of the part that you're trying to make, and having the final one that's dimensionally accurate is super helpful. And then even as far as building the CNC machine, because that machine that I have is heavily modified. I built most of it. Being able to create brackets, non-structural, but if you need to route wires, you don't need a structural part. You just need a part that's very specific to what you need the routing.
Yeah.
And all of the parts are 3D printed. The tolerances are made exact by the jigs that I built 3D printed to build it. A lot of that machine, I couldn't even build that machine as it is without the 3D printed parts that I made for it.
Right. And I think that I want to keep an eye on and giving you guys the option to talk back to us, because I'm really interested in hearing out the comments. But to round things up a little bit for the method part, now being able to use the method to print things and using the PVA supports, as we were saying, it's a different type of support structure where it's simply it dissolves in water. So you still have the same part. I'll bring it back here. You don't have to zoom in completely, but it's just this big chunk of PVA that just goes away once you dunk it in water. You have improved accuracy, right, that we talked about. It's a different build volume altogether. It's a different machine for that. But it does...
There's definitely pros and cons to both machines.
Correct.
But the method, having the PVA supports are great. If you look at this Z18 printed part that I printed, you still have minor support, parts of the support. I could go in there and clean it up, but as far as time, I didn't need it. Whereas with the PVA, it's a perfect print right off the bat. And that's, super cool.
So... I think it speaks to going back into the slides, the amount of tests that go into these machines, that making sure that they are going to work reliably for somebody in the shop who's trying to use them, and kind of rounding up the two options, right? Before we get into the Q&A, but the C18 and the method as a pro offering, right? In a way, you have on one hand one massive machine that's kind of great for printing parts in a single go, super fast. They're going to rely on a single extruder, so that means a single material. And then on the other hand, you have method with PVA, the increased accuracy. It comes, you now have to dissolve the supports, so you're no longer just removing them. So if I have, the part on the C18, I can just crack the supports here and remove them by hand. It's fairly easy. In method, you'll have to dunk it in water for a few hours before it goes away. But it's kind of a two different machines that work well
Yeah.
in the workshop, right? And
Sure.
kind of just the big announcement today is the fact that we are now shipping Method. So we've been working on it for a while. Finally, it's live in the site. You're more than welcome to order it, and it'll get to you in a few weeks. I'm really excited for that. Been using the machine at all, and well, quite a bit, and now with you too. But with that, I'd like to open the floor a little bit for questions, from you guys out there. I don't know if we have any already slated for us to talk about.
What are the benefits of printing on a Method or Z18 compared to just outsourcing my parts to a service bureau?
Okay, so I'll recap the question, right? The benefits for on printing, in a Method and a C18 versus outsourcing. I'll get started and you can continue after
Sure.
that. But I think that it comes down to the time and the money that you spend on the outsourcing, right? It's going to take, instead of you turning around and printing it in the shop, you have to wait for something to be done, shipped over probably at least a week, and then you'll be able to react. I don't know, what's your experience with that?
Kind of like what you said, it comes down to the value of your time. This costs a few dollars. I could print this for less than $5, and I could print it and have it immediately. Whereas, if you outsource it, you have to make sure the file that they take is the file that you have. So you deal with that. You deal with the time it takes to, have them print it and the time it takes to have them ship it. And then if you go through all that and it's wrong, and you just spent weeks working on something, or at the minimum a week working on something to get it back, and it's wrong. Whereas if you design it yourself and print it yourself in-house, it's a day at the most if it's a very long print, Yeah,
and it's funny, because I used to have back in the days, but like my own printing shop, my own company, and it's funny how fast you get to offset the cost of the printer because of the fact that, so if you print it in-house, this part is $5. If you print it outside, it's also going to be way more expensive.
For sure.
Probably you're talking for something this big, you're talking about couple $100. So it really stacks up fast, I'd say. That's kind of the take on both of them.
What is the process for switching filaments from PLA to PVA to build supports within the Method printer?
Okay, I'll take that. Basically, as we've talked heavily in past webinars, in Method we have two extruders and two material choices, right? For that, we have two drawers here. So basically,
Sorry, Felipe, what was the question?
Oh, sorry, the question, right. The process for changing between PLA and PVA in Method. So what happens in Method is that unlike the C18, and I'll open the C18 in a second, but you have two drawers, and these drawers, these drawers are going to be dry sealed, right? So it's actually controlling the humidity and the temperature on the filament, not only just passively containing them. The second drawer here contains actually the PVA, and we talked a little bit about the fact that the PVA is really sensitive to humidity,
For sure.
which is why it's so important to keep it enclosed. So you don't really change materials in Method, but you have the two extruders available for you to use at any given point. You can see them here. I don't know if you'll be able to pan into, but basically there's two extruder heads inside of the machine. And the machine toggles between them, right? It's using either the PVA, right, or automatically as it's building the part. That would be kind of the way. You don't do it yourself. It's just the machine toggling between the two drawers, the two extruders, and then basically giving support where support is needed and the material where the material's at.
What materials and colors can the Z18 print in?
Okay, materials and colors for the C18. I'll let you talk about your experiments a little bit, but I'll start with.
if you look online, there's almost every color available now in PLA. It's crazy.
I mean, for MakerBot side, we
all
support like 24 colors in PLA, and then we have 4 colors available in Tough, which is a more robust material, better for if you're drilling on it or trying to machine it a little bit, not machining, but like at least drilling or carving it some. For Tough, we have 4 materials. For PLA, we have 24. But yeah, online, there's other options that people can definitely look at and experiment with. Oh, especially right now with the experimental extruder, there's a bunch more which are not only color materials but also different property materials like we were talking about.
What is the total build volume for the Z18, and what are projects that designers or engineers have used that build volume for?
Okay, so total build volume for the Z18 is going to be, I'll give it both in metrics and imperial. I'm a metrics guy, but in imperial it's 12 inches by 12 inches by 18 inches, hence Z18. And then in metric it's going to be like 300 millimeters by 300 millimeters or 450. And the things that we've seen, we've seen anything from here with Max, the handlebars. We did a case study with Kuka. I recommend that you guys watch it out. Watch that one out. They built a full-on robot, right? And again, they're not printing the full thing in a single go, but they're fitting each of the components. And we showed it in the last webinar. Probably some of you guys remember that, where we printed a robot that's probably like 5 feet tall. It's a robotic arm. We've seen it a lot in car manufacturing. So larger components like hubs for larger axis, the wheel axis in the car.
I've seen prosthetics. Prosthetics are really cool.
Right.
I've actually seen that quite a bit, and it's really cool.
Like
people like designing and printing their own prosthetics, which is like amazing.
Yeah. And yeah, I think that would cap it up. I thank you guys for joining. Be sure to send us your comments and any suggestions of future webinars at hello@makerbot.com. And I also want to thank Max a lot. Thank you for being here. It's been great. I think we're really excited, especially to open the mic to people outside of MakerBot and seeing how you guys use the machine. How does it work for you guys?
Yeah.
And anybody out there who wants to give a shout out here, we're more than welcome to join. But yeah, thanks all for joining.
Thank you.
I'll reiterate the site, hello@MakerBot. If you have any comments on future webinars, on this webinar, things that we can improve on or that you like and dislike. And also, your website is C4CycleWorks.
Yeah, C4CycleWorks.com, or on Instagram at C4CycleWorks.
Yeah. Oh, yeah. There we go. It's right here on his shirt. It's pretty cool. His work. I'm amazed by all of the things that you've developed. It's a really cool account to follow for sure on Instagram. So thanks everybody for joining. We'll see you next time. And have a great Thursday.